Hey, Travis, I'm excited. We're going to talk about MLPEs today.
Hey Trish, yeah, you are aware of how I feel about MLPEs, so let's get into it.
I am. But let's start with some introductions. I'm Trish Morato, Senior Comms Manager with SMA America. I'm chatting today with Travis Davis, who is our Territory Sales Manager for the Northwest. Travis has just published a blog piece, Straight Talk Solar, about his strong disdain for MLPEs. So, Travis, why don't we jump in?
Yeah, they don't make any sense in my mind. One of my coworkers, Brett, actually coined the phrase, "It's like giving yourself a headache so you can take an Advil." So I have to give him credit for that line. But like humans, we're creatures of habit. Life is busy. Once we start something, we generally just kind of roll with it until strong enough evidence or pain is presented otherwise. So, I personally have been working in the industry for about 8 years as a system designer, now as a territory manager. And again, the evidence, I think, has become overwhelming to me that MLPEs aren't the right solution.
Okay, Travis, so let's break it down. What's one of your biggest issues with MLPEs?
Yeah, so of those, I have many. I'm sure we'll talk about them, but let's just start with system reliability. So, and actually, historically, there's a period of time kind of spanning from about the mid 2010s through like the early 2020s, where the general philosophy of residential solar sales was that microinverters were advantageous because if one microinverter goes out, you only lose one panel, as juxtaposed to a single inverter responsible for the entire system, where if that inverter went out, the entire system would be down. That line of thought tracks well if you don't spend too much time thinking about it.
Yeah, I don't think anything actually tracks well if the caveat is don't spend too much time thinking about it.
Yeah, agreed. And what really plays out in the field bears fruit on the side of a quality made string inverter. We need to be honest about what the failure rate is for solar panels. And according to a 2017 study from the National Renewable Energy Laboratory, or NREL, 0.05% of solar panels installed since 2000 will need replacement due to failure from age, exposure to elements, or manufacturing defects.
So 0.05%. That is an incredibly small amount.
It is. The kind of going back to, it's like giving yourself a headache so you can take an Advil. If an MLPE is giving an error code, it is far more likely that the MLP itself has failed. So it rarely has anything to do with the solar panel itself. The MLPEs are monitoring themselves effectively, not the production of the panels. So from the standpoint of reliability, right, electronics, they do not like extreme heat, cold, water exposure, or just general fluctuations in climate. But that's exactly what they are exposed to on the roof day in, day out for years. So, the better approach is to let the panels do their work on the roof, bring the DC current off the roof, and do the conversion to a usable AC current in the garage or the side of the home, somewhere in an accessible location with a more controlled climate. So strong architecture is going to allow for the best long-term satisfaction for homeowners, while giving install companies an easier and less expensive fix if that's ever an issue.
Right. Well, and system reliability is one of the key factors to consider when developing your system. So that's a no-brainer. You also write in the blog about the ease of maintenance and repowering. Can you explain to me a little bit about how MLPE comes into play here?
Yeah, sure. So if an inverter registers a failure, generally the homeowner, they're not going to have any idea, what's wrong. They're going to call their installation company, and that company is going to have to truck roll out to the site to diagnose the issue. So if you're using MLPEs, that's going to now involve climbing on the roof, locating the device registering an error, right? From there, an installer is going to have to figure out the path forward, depending on the time span since the original installation. A lot of these MLPE models will no longer be available. So that's going to cause compatibility issues in tandem, again, just like with a more physically challenging fix.
Right. What an unnecessary hassle. So what's a more ideal situation?
So, again, just talking about system design and system architecture. So with the Sunny Boy Smart Energy, a service technician can literally just walk up to the inverter to perform any required work. There's an additional free service offered for the Smart Energy, which is called SMA Smart Connected. This is actually available for all of our inverters. It is a free platform that can initiate remote RMAs or return merchandise authorizations. It's just, if hardware goes wrong, you're going to get it sent to you because inside of the Sunny Boy Smart Energy is a system manager. It's literally built into the inverter. So as long as you've registered for Smart Connected, in many instances, this is going to negate the need for an installer to roll a truck for diagnostics, which is going to save them both time and money. And just to note, the replacement inverter lands at the specified address when they register for Smart Connected.
Right. Plus, with repowering, there's no issues with single device incompatibility. And with the SBSE, it can be used to repower almost any string inverters, right?
That is exactly correct. So the Smart Energy, was also designed, kind of to your point there, was designed with a really wide voltage window. So for some of these older systems, that are maybe, 15, 20 years old, it's actually that wide voltage window is going to allow for recapture of some lost kilowatt hour production, which again, it's just going to be a really big advantage for installers, especially like in NorCal, in my area. There's a lot of systems in that 15 to 20 year range, and they're going to need new inverters to carry their systems forward. And the Smart Energy is that solution.
So, that SMA globally is really dedicated to sustainability. In our subsidiary, we've been making a lot of changes to the way we do business recently to have a keen eye on making the most sustainable choices possible. And we're in an industry specifically that does drive a lot of new technology to conserve the environment and move away from fossil fuels. How does the choice of MLPE versus no MLPE fit into these sustainability goals?
Less is more. So for the same reason that, SMA believes that, less electronics and failure points equals higher yield, reliability, we also believe that less components just equals a better environmental outcome. There's just simply less to recycle, less possible trash. It's an easier breakdown when the product has reached the end of its usable lifespan. Again, it's something that is often not thought about.
Right. It makes all the sense in the world. Less is more, simpler is better, and in this case, safer, right? Not just safer for the system, but safer for the earth.
Yeah, correct. And, there is one more point that I do want to make about why MLPEs don't make sense to me. So along, right, with offering less failure points, just less opportunity for things like e-waste, not utilizing MLPEs also achieves something even more tangible, which is less money spent.
Walk me through the actual numbers here. What kind of costs are we talking about?
Yeah, so it's going to depend a little bit on your installation area, but the average microinverter is going to cost somewhere in the neighborhood of about $150. So if you have a project that requires, say, 25 400 watt solar panels for a 10 kW system, That's going to require 25 microinverters, and that's going to total out to $3,750 just for that component. And as systems get larger, that cost discrepancy only grows.
And how do the projections about higher adoption of storage impact that ROI?
Yeah, so another feature of the Sunny Boy Smart Energy is that it has a 200% DC to AC ratio, which is massive. In the past, and if you're talking PV only, you're not going to oversize your system that much. But in those scenarios where you're including a battery with your installation, you can really load up the PV on the Smart Energy inverter, and for whatever excess current exists that's not being used by your house, it's not going back to the grid. That excess current can literally fast charge the battery. So having that 200% DC to AC ratio is really advantageous. And over time, that architecture of the Smart Energy will yield the best levelized cost of electricity for both homeowners and installers. So on the install side for installers, there's cost savings in their service budget. Smart Connected is going to alleviate truck rolls for diagnostics for them. And if they do have to go do a fix, they're not going to have one of their employees go crawl around the roof and figure it out. They can literally just, again, walk up to the inverter, do the fix there. On the homeowner side, the Smart Energy also provides the best levelized cost of electricity in the form of another seldom discussed issue, which is actually losses due to heat.
Yeah, let's talk about that, because we don't hear people talking about the loss due to heat that often. And it makes sense. If you think about it, microinverters and DC optimizers are constantly running, right? Which generates heat. And especially if you think about it now, we're in the summer. I imagine having a single inverter in a controlled environment is really going to be impactful to help with the loss of heat.
Yeah, that is, again, absolutely correct. And every solar panel out there, inverters as well, have something called temperature coefficients. It basically states that as temperatures rise, output reduces. Those MLPEs are up there just constantly running. That's generating heat, right? So by locating a single inverter off the roof, the Smart Energy is actually allowing the PV modules to reach their full potential for energy production, because there are no heat producing MLPEs up there, which again are actually reducing the output of the panel. So we are letting the panels do their thing on the roof. We take that DC current off the roof and do the DC to AC conversion in our air-cooled inverter. So again, over time, it's a double whammy of positive features. It's, you're spending less money, less CapEx investment, and less production losses over time.
Right. That makes sense. All right, let's zoom out a little bit. We've covered a lot of ground today. We've talked about system reliability, repowering, sustainability and environmental impact, and the ever important for someone that works in sales like you do, the ROI. Travis, is there anything else you want to touch on before we wrap up?
I think we hit all of the main things that I wanted to chat about, and I appreciate the time, Trish.
Okay, thanks, Travis. Everyone be sure to check out Travis's blog post, his Straight Talk Solar post on the SMA Sunny blog. And thanks so much, Travis.
Thank you. Have a good one.